Hi, algebra students. So today will be your first section of notes from our new unit on polynomial equations and factoring. So let's go ahead and get started. In lesson 1, we're going to take a look at some vocabulary that's going to help us understand how to classify polynomials. So I think you saw this first term in some of our previous work. That word is monomial, and a monomial is one term or just a number. A binomial, think of like the word bicycle. A binomial is the sum of two monomials. A trinomial, just like a tricycle, is the sum of three monomials. And a polynomial is the term that we use for the sum of four or more. So anything that has four or more terms is just called a polynomial. It's a general term. A degree of the polynomial is the largest or highest, however you want to word that, the largest exponent of all the terms. We'll discuss this a little bit more tomorrow. Okay, our next term is standard form. In standard form, a polynomial is written in terms of the largest exponent to the smallest. We'll see an example of this in a little bit. Okay, and then your next term says when a polynomial is written in standard form, the coefficient of the first term is called your leading coefficient. So just know that we'll refer to that vocabulary quite a bit. Okay, so let's put some of this into action down here. So it says write the polynomial below in standard form and identify the leading coefficient and degree. So in this first one, again, we want to look at our largest power of x. So notice we have three terms in this example. Our largest power is x to the fifth, so we would start with 4x to the fifth power. And then in decreasing order, we go 3x squared and then minus 7x. Anytime you're moving terms around to put something in standard form, make sure you keep the sign that precedes the number. Okay, so over here, LC means the leading coefficient. So what is the leading coefficient of this polynomial? And that's the number 4. The degree is the largest exponent, remember we talked about. So this is a 5th degree polynomial. Or to be more specific, a 5th degree trinomial. It has 3 terms. All right, let's look at the next one to the right. So this time we have 4 terms. Our largest exponent is 4, so we're going to start with the 2y to the 4th. Notice I put the subtraction sign in front of that because it is negative. Then minus 6y cubed. That's actually plus 5y. 5y is positive, and then minus 9. Our leading coefficient is negative 2. Make sure you catch that sign. Our largest exponent is 4. So this is a 4th degree polynomial. Remember, it has 4 terms, so we just use that general term polynomial. Okay, why don't you try the next 2, and then we'll go over those in class tomorrow, and I'm going to keep on moving forward. Okay, so the next thing we're going to do is learn how to add and subtract polynomials. So how do we put these together or take them apart? So depending upon what the problem is asking us to do. So when you add polynomials together, it's really just kind of like combining like terms. So you can do this one of 2 ways. If you notice, all the problems are written horizontally. So you can leave them horizontal if you want and just combine like terms that way. Some people like to stack the terms on top of each other. So I'll show you one of both. So for example, when you're combining, it's important to make sure you're paying attention to your exponent. Remember, you can only combine terms if they have exactly the same exponent. And you always want to keep your answer in standard form, so always start with the largest exponent. So for example, here I'm going to start with this first term, 5x to the 4th. And if I look over here, there's nothing else that contains an x to the 4th power. So I'm just going to bring that one down. let's see, looking through that set, the next largest term is this one here, 6x cubed, and there's nothing else that's being cubed. So I'm going to put that one next. And then I'm going to go to x squared. So notice I'm just working in descending order. This time I have a negative 3x squared and a negative 4x squared. So when you combine those, you get negative 7x squared. And then always end with your constants. So I have a positive 4 and a negative 7, which gives me a negative 3. And that's your answer. So you're done. Okay, we're going to go to the one at the right, and this time just to show you something different. So I have this trinomial, and I'm adding a binomial to that. So if you like to combine terms by like just stacking it, so you have 4ab, whoops, that should be a b, not a d. Let me fix that real quick. Don't want it to look confusing. So 4ab goes underneath there, and then you have a 6b squared. So make sure that goes underneath the b squared. So you're just aligning like terms vertically. So like if you were copying this out of the book or something, then you could, or if you were copying it on your paper, you could write it this way if you prefer. It really doesn't matter. It's just personal preference. And then you can go left to right or right to left. So here, like I have nothing underneath the 3a squared. So that's all I have there. I have a positive 3ab and a positive 4ab, so that gives me 7ab. And then negative b squared plus 6b squared is 5b squared. Okay, what you might be noticing here is we have two different variables. So when you have more than one variable, you go in alphabetical order, and you start with the largest power of the first, and you go in descending order. And then you go in ascending order of the second variable, just like you see here. We can discuss that tomorrow if need be. All right, so let's look at a little bit of subtraction. So this time, the important thing to remember about subtraction is it does get a little tricky because you have to remember that there are parentheses around the second part of the problem here, which means we're subtracting everything on this side here. Okay, so you just really, really need to be careful with your integer rules and pay attention to your signs. So for example, I have 5x cubed and I'm subtracting 8x cubed. So that means I have a negative 3x cubed. Okay, and then I'm going to go to my x squared. So I have a negative 7x squared. And I'm subtracting 2x squared. So negative 7 minus 2 is negative 9x squared. Next I have 3x, and I'm subtracting a positive 3x, so those terms actually cancel out. So I just end up with 0. You don't need to put 0x in there. It's not necessary. And then lastly, I have a negative 4, and I'm subtracting a negative 7. So this is a good time to talk about, like with subtraction, you might want to change your subtraction to addition and then just change all your signs down the line. So like this negative 7 becomes a positive 7, and then you can just add. So negative 4 and a positive 7 is a positive 3. So there's my final answer. All right. So with this one, I'm going to show you again how to stack them if you want. You'll notice, again, we're subtracting this, and with subtraction, order is important. So everything here is getting subtracted from this first trinomial. When you line up terms, just notice this one is not in standard form, so you need to line them up correctly. So what you might want to do first is that stay, change. So change the subtraction becomes addition, and everything over here changes signs. So you're adding the opposite. That's the definition of subtraction. So if you line up your like terms, you have a negative 7x cubed. You have a negative 2x squared. And then notice you have a positive 6x to the 5th. So that's going to go here. Okay, and then now since you already fixed your signs, you can just add everything. So 9 and 6 is 15x to the 5th. 6 plus negative 7 is negative 13x cubed. And 7 plus negative 2 is a positive 5x squared. Finished with that. Okay, so I'm going to have you try the next set of problems on your own. Please notice we're doing exactly the same thing we just finished, although everything is written in what's called function notation, so you've seen this before. So down here, for example, you get you have the function f of x and the function g of x, and it says find f of x plus g of x. So it just means you're adding x squared minus 6x plus 5 and 2x plus 3 together. And then the same thing on this second problem over here. You have two functions, actually exactly the same two functions. This time you're just going to subtract them. So I want you to try those two on your own. We'll check over those tomorrow in class, and we're going to take a look at your application. So let's look at, this is our geometry application, which we typically do. So the first problem says write an expression for the perimeter of the figure. So first of all, we've been talking a lot about area. So let's think back to perimeter. Remember, perimeter means the distance around an object. So that means add up all the sides. So that means you have two sides that are, so you have this 3x squared plus 5x minus 2 is the same here. Top and bottom are the same because it's a rectangle. And then 5x squared minus x plus 8. So it's the same thing all the way around. So just remember we're combining all of our like terms. So I'm just going to put all these, so like think about your perimeter formula is just side plus side plus side plus side. So add them all together. Okay, so we have 3x squared plus 3x squared is 6x squared, and then 5 and 5 gives us 10. So 10 plus 6 is 16x squared. Then let's go to our x terms. So we have 5x and 5x, which gives us 10x. And then we're subtracting 2x from that. So that gives us a positive 8x. And then we're going to go to our constants. 8 and 8 is 16. Negative 2 and a negative 2 is a negative 4. So 16 take away 4 is a positive 12. So the area, sorry, I almost said area, perimeter of this figure in simplest form is 16x squared plus 8x plus 12. Okay, so this time the next one's a little bit different. I actually think I'm going to save these next two problems for class tomorrow, so you don't need to do these two problems. Just save the next two application problems and we'll talk through those in class tomorrow. I hope that you've gotten a good introduction. We will definitely review everything when I see you in class tomorrow. Have a great night.